Today we are going to look into equations with variables on both sides, and we are going to make an introduction to the function form. When we are solving equations with variables on both sides, we are going to continue using reverse order of operations. Our acronym for that was DCVAM. We're going to undo any distributive property first. We're going to combine like terms. We're going to isolate the variable on one side of the equation. We're going to undo an addition, and then we're going to undo multiplication. Undoing addition and subtraction will be done at the same time. Undoing multiplication and division would be done at the same time. Here is our first example. We have variables on both sides. On the right side, we have 2x and negative 5x. We can combine those first. There are no distributions to be done in here. On the left side, we have 3x minus 4. On the right side, I have negative 3x plus 8. Our goal is to isolate the variable on one side, so it would make sense to isolate them on the left side because we will be dealing with positive variables. If I add positive 3x on each side, these will add up to 0. You will have 6x minus 4 is equal to 8. Now we're going to undo a subtraction by adding 4 on both sides. We will have 6x is equal to 12. Last step is to undo a multiplication by dividing each side by 6. X will be equal to 2. Now let's do a check step. We will substitute our answer into the original equation. 3 times 2 minus 4, is it equal to 2 times 2 plus 8 minus 5 times 2? We will use order of operations in here. Multiplication before addition and subtraction. 6 minus 4, is it equal to 4 plus 8 minus 10? 6 minus 4 is 2. Is it equal to 12 minus 10? 2 is, yes, equal to 2. This shows that our answer, x is equal to 2, was the correct answer. Here is one you try for you. This one has a little distributive property. You're going to distribute first and then go through our steps. Now we look at the different style. It is variables on both sides with fractions. We have two different methods on solving equations involving fractions. One is just simply doing fraction operations. First, we need to isolate the variable. Subtract 1/2 from each side. Subtract 1/2 m from each side. We would have 5 over 8 m minus 1/2 m minus 3 over 8 is equal to 7 over 8. To do a subtraction, you need to expand the fraction by 4 so that we will have a common denominator. 5/8 m minus 4/8 m minus 3 over 8 is equal to 7 over 8. We will do subtraction between m's here. We will have 1 over 8 m minus 3 over 8 is equal to 7 over 8. We will add 3 over 8 to each side. 3 over 8 on both sides. We would have 1/8 m is equal to 10 over 8. To solve one more step here, we will multiply each side by the reciprocal, 8 over 1. Multiply each side by the reciprocal, 8 over 1. These will cancel. M will be equal to 10. The second method of solving this is that if we will get rid of the denominator completely. And when I look at the denominators, I have 8, 8, 2, and 8. least common multiple of these denominators is going to be 8. So if I multiply each side of the equal sign by the denominator, by the property of equality, I can do that. And after we do the distributive property, it's going to cancel the denominators. So our equation would turn into 5m minus 3 is equal to 4m plus 7, excuse me. Now, please be careful with the distribution in here. When we distribute 8 to 1/2 m, we multiply 8 times 1 and divide by 2. That's how I got 4m. Now this looks much simpler. We can isolate the variable by subtract 4m from each side. Subtracting 4m from each side. m minus 3 is equal to 7. We will add 3 to each side. M is equal to 10. We found the same answer. We can also confirm whether our answer is correct or not by using our check step. Here's our check step. 5/8 times 10 minus 3/8. Is it equal to 1/2 times 10 plus 7/8. I'm going to expand the second fraction by 4 so that I can have the common denominator to add. 5 times 10 is 58 minus 3/8. Is it equal to 48 plus 7/8? And then it turns out that we have 47/8 is yes equal to 47/8. That confirms our answer was correct. Here is your U-try. If you decide to use canceling the denominators, please remember that I multiplied each side of the equal sign with the denominator. In that case, if you multiply each side by 5, please make sure to distribute it to every term that's inside the parenthesis. In this case, it will just multiply with this. Now let's look into function form. Function form is also called the slope-intercept form. It's a type of linear equation with two variables, x and y. And we always solve for y, which means y is isolated. The formula for function form is going to be y is equal to mx plus b. M is going to be a number multiplied by x, plus b is going to be another number. Now we are going to look into the function form. Our goal is to leave y alone on one side of the equation, and on the other side we will have x multiplied by a number and plus a number. Here's the first example. We have negative 5y here. It would be easier if you would have had positive y value, and since we want to have the y value on the left side or only on one side, we can add 5y on both sides. This will give us 5y plus 4 is equal to x. We can undo an addition by subtracting 4 from each side. 5y is equal to x minus 4. I can divide each side by 5. When I divide each side, I need to draw a big fraction bar to divide the other side completely by 5. These are simplified. The other side of the equation is going to be x minus 4 over 5. This cannot divide or simplify any further, so this would be our function form. However, it doesn't look like this form yet, so we're going to expand this one more step here. This is already in subtraction. So it's same as having two fractions subtracted. So I could write x divided by 5 minus 4 divided by 5. My final form would be y is equal to x over 5 minus 4 over 5. Here is your u-try. Please try to leave y alone. Here is your u-try 4. You're going to solve this one for the unknown variable. Make sure to use your distributive property. Use your DCVAM steps and solve for n. That's pretty much it. If you have any questions, please make sure to bring it to class.